So I'd like for us to try this piecewise defined function here, but before we get there, just a quick FYI. Recall that piecewise defined functions can look something like this, where you have just a bunch of scattered pieces sort of put together, where the tendency is that there's a piece that takes you to the left, a piece that takes you to the right, with all kinds of craziness taking place in the middle. We can expect to see open, closed, open, closed, open, closed circles all over the place. And there's really no rhyme or reason to this. It's just whatever happens, happens. So let's go back here. I have 3 pieces, so my eyes expect to see 3 shapes at the end of the day. Maybe some open, maybe some closed circles. What I would do is I would make a table of values for each of the 3 pieces. Now, before we go any further, just a quick note. It's really helpful to be able to recognize the parent functions. You see, that's a square root symbol. And a square root function tends to look something like this. Sometimes it points up right, sometimes it's down right, sometimes it's up left, sometimes down left. Now the middle piece, that's an absolute value function, which tends to look like a V. Which part of the V are we going to end up seeing? We don't know, we'll see what happens. And of course the parabola is, your quadratics is something like that. Sometimes up, sometimes down, maybe even left and right. But I think in this case, it's just either going to be up or down. So now I need to fill out my X column. How do I know what X's to use? That is decided by these parts here. So for instance, for this first piece up there, I need X values that are less than -4. What's less than -4? -5, -6, -7, and so on. Can I use -4 itself? No, but I am going to be rebellious and I am actually going to write it in my table. Now I have to be less than that, right? So like -5, -6, -7. How many points do you need in your X column? It's your decision. The more points, the more accurate. Typically speaking, 3, 4, 5 points will suffice. Now, because I was being rebellious and used a number that I did not have permission to use, I am going to remind myself that is actually going to create an open circle. Now, how do I fill out the Y column? You always take your X's, plug them into whatever this is, and drop the numbers there. Now for this piece here, I need X's that are between there and there. Do I have to use all the numbers that are in between? No, but I do want to use the beginning and end. So let's go like -4, maybe -2, 0, 1. Now again, because I did not have permission to use 3, because X had to be less than 3, I'll remind myself that this is actually an open circle. And let's fill out this Y column. And over here, I need X's that are greater than or equal to 3. So how about 3, 4, 5, 6? And let's fill out the Y column. So all of our tables have been completed. Now it's time to create a graph, plot the points, connect the dots, and we're done. Okay, so let's start with these ones here. So let's go to -4, 0, and let's plot an open circle. 1, 2, 3, 4, and that has to be an open circle. Make it really dramatic that it's open. -5, 1, and then turn these into decimals and graph them approximately so, maybe like here, and then -7, 1, 2, 3, 4, 5, 6, and then that's going to be about 1.7-ish, I believe, something like that. Now, how do I connect these points? Is it with a line or is it with a curve? Well, these points are coming from here. That's a square root operator, which looks something like this here. So I am prepared to draw something like that. It doesn't have to point to the right. It can be left, right, or up or down. You see, if there's a negative on the inside, it's probably going to point to the left. If you do not have a negative on the X on the inside, it's probably going to open to the right. If there is a positive on the outside, it goes up. Had there been a negative on the outside, it would have gone down. So the inside negative on the X controls left, right. Any negative or lack thereof on the outside controls the up, down. So I am going to draw these points and connect them like that. And it goes to the left forever because this piece takes me to the left forever. Now let's plot these center pieces here. So now I have an arrangement which looks to be appropriate because these are coming from an absolute value, which looks like a V. Now, how do I know if I have captured the vertex? You see, what you can always do is whatever is inside the bars, write it down, let it equal 0 and solve. And the number that you get is the X coordinate of that vertex. So here, the X coordinate of the vertex was -2. which I happened to include in the table of values, convenient, and that was this point here. So that's the vertex. And so when I connect these points, I must respect the fact that they are contained in this window only. They will not extend beyond because I only look like this V during that time. For that reason, I don't have an arrow here or here, but I do have closed and open. So I have this arrangement here, and that makes sense because this is a parabola, which is a quadratic. So it should look like this here. Let me just draw this carefully, come back down. And as it goes down, this one has an arrow because this is the rightmost piece. So it has a right arrow that takes you this way. The absolute value pointed down because this was negative. The parabola pointed down as well because that was negative. This piece has an arrow. This piece has an arrow. Do the middle pieces ever have arrows? Sometimes yes, sometimes no. Typically speaking, not really. And so again, we relied on a table of values along with recognition of the parent functions and open circles, closed circles. So put all those pieces together, try your problem, and let's see how it goes.